So we're going to do quite a bit today, but we're working through what systems are and solving systems graphically and algebraically. So what is a system? It's a grouping, a set of two or more equations. And for purposes of early on here, we're going to just be dealing with ones that look like this, meaning two linear equations. And what we mean by what it looks like to solve a system is that you are looking for an intersection point, x comma y. And so you're going to graph two lines, and these two lines may intersect, in which case you would have some point xy, one solution. They may be parallel though, because lines can be parallel, and in which case you're not going to find a point that both lines have in common, so this would have no solution. This is when you start graphing, start solving an equation, and you get 0 equals 2, and you get a false statement. That's what's going to happen in when you start solving it algebraically. And then the other possibility is that it could be the same line. One is a multiple of the other. And so you're saying, well, wouldn't I notice if these equations were the exact same? But it could be that one is 4x plus 6y equals 26, and maybe you don't notice it right away because you just get into solving it and are really excited about canceling out variables, whatever it is. One is a multiple of the other, in which case the solution, you would get a 0 equals 0, a true statement, because you actually have a solution, it's just a lot of them. And so what the answer might look like is all points on y equals ... So all points on the line. Alright, so there are multiple ways we can solve systems. We're going to solve it graphically, we're going to solve it by substitution, and then do it by elimination. So graphically, of course, we're going to have to graph it. So let's do this bottom one first, just because it's a lot easier. So negative y equals, let's subtract the x. I'm going to put the x first, just because that's what we're used to seeing it in slope-intercept form. And then y equals positive x minus 9. Remember that we could also have used the x-intercept and the y-intercept. So x-intercept would be 9, and the y-intercept would be negative 9 if you're plugging in 0 for x and y. So 1, 2, 3, 4, 5. A little off the page there, but this is what we're looking like. And then 2x plus 3y equals 13. So 3y equals negative 2x plus 13. Divide by 3. Negative 2/3 x plus 13/3. Now, I didn't explain how I graphed this other one, so let's go back. Negative 9. This is in slope-intercept form, so the intercept, the y-intercept, is negative 9. So I went down to negative 9. And then the slope is 1, so I went up 1 over 1, up 1 over 1, and continued. So 13/3, 12 divided by 3 is 4, so this is 1, 2, 3, 4, plus an extra third. So we are going to go down 2 and over 1, 2, 3. I'm just going to stay up a third every single time. Down 2 and over 1, 2, 3, down 2 and over 1, 2, 3. So, we've graphed it. Unfortunately, the problem with graphing is it's not exactly accurate, especially because we are human, and graphing 13/3 is a problem sometimes. But this kind of looks like 1, 2, 3, 4, 5, 6, 7, 8, -1. But it kind of looks like it may have been past it. But approximate 8, -1. I like graphic because it gives you a good picture. I don't like graphically because it's not very accurate. So let's try it by substitution. Substitution is when you solve for one variable and plug into the other. Solve for a variable, plug into other equation. Alright, so it's easiest to solve for either x or y in this one. And so what I'm going to do is take your second equation and say x equals y plus 9. And then we take that y plus 9 and plug it into 2x plus 3y equals 13. And we take this and plug it right there. So 2 times y plus 9 plus 3y equals 13. These are, say this is x is $1 and we're sticking 4 quarters in there. They're equivalent, at least at this one point that we're trying to find it. So 2y plus 18 plus 3y equals 13. So we get 5y plus 18, and then let's subtract 18, so 5y equals -5, and divide by 5 and you get -1. The key here, don't stop here. Plug y back into either one of these equations. I'm going to plug it back into x equals y plus 9. So x equals -1 plus 9, so x equals 8. And so our solution, 8, -1, was in fact a good approximation graphically, although it didn't look like it was exactly on 8. Let's try one by linear combinations.